Yes, I am here. I made it. Hey everybody. I'm late. I'm late. I'm at least a half an hour late. Terrible. Terrible how things go sometimes, but hey, I am here. Welcome, welcome, welcome. It is 2:46 UTC, and this is the late edition of Astronomy Daily Live. So, yeah, hey, glad everybody could hang in there, wait for me to get home. Had to do some traveling. Had to do some traveling and just walked in the door now. Got in, just pulling up my chat and seeing that everyone is already here. Yeehaw! Yeehaw! Yeah, it's about time. It's about time. That's what happens when you have uh, well, no, I won't go there. So yeah, hey everybody. Hope everybody's doing well. I'm going to keep this relatively short. Not what I would do today. Let's look at the sun. Let's look at the sun. Put your blinders on. No. This is a safe way. Um, uh, we're going to be looking at just a couple of sites that I like to go to sort of get an idea of space weather and awesome pictures of the sun. So one of the sites, I'm just going to dive right in. I'm not even going to do a homily or anything today. um, I'm just going to start sharing my screen right away. And I think I put a link to at least one of these things over on my Discord, but I'm gonna actually start uh, somewhere else first. Uh, I'm going to start at a thing called spaceweather.com. Spaceweather.com. This sort of will get us in the mood. Get us in the mood. So this is a really great site just to give you a basic idea about what is happening in the environment, in the space environment around the Earth. And yeah, this is a cool site. I've been looking at this for years and years and years. Um, uh, yeah, not a heck of a lot of information, but usually some pretty cool stuff. Um, talking about the solar wind, the density of the solar wind. Yes, that is almost 5 protons per cubic centimeter. So you know, space is not quite empty, but even relatively dense like that. At least relative to things here on the Earth. Phew, that's a vacuum. That's a vacuum. So yeah, spaceweather.com is okay, but I'm going to show you a couple other sites too that I like. More looking at the sun than anything else. But I think a lot of these things are you can see little plots. Yeah, yeah. So you can look at the solar wind speed. So down here is I know it's small. This is the UTC time. So you can see it's almost 3 hours UTC here, 1 hour 23. So you can see, that the solar wind speed has been pretty steady, right? Maybe around 350 kilometers a second or so. And, you know, density maybe around 4 or 5. Pretty steady, pretty steady. Phi angle, temperature, right? There was a temperature jump here. Um, we're in a regime of 100 million degrees. So the temperature, however you want to define what the temperature is of of the solar wind at the Earth, right? It's 100,000 degrees Kelvin. So some pretty serious stuff. So yeah, you know, I should say hi to everybody in the chat. I see that Jill is there. Miss Lady Catherine, Tom is there, Bobby is there, Patrick is there. Haven't seen Uncle Bill yet. Haven't seen Uncle Bill yet today, but yeah, hope everybody's doing well. Everything's okay here. Just you know, just running a little bit late, but you know, this live stream is very casual, very fun. I don't sweat these kinds of things at all. You know, I try to let you know if I'm going to be late and how late, but you know, sometimes that doesn't work out either. So I really appreciate you all hanging out. Usually, what I'll do is I will send a message over to my Discord server. So you can find that. It is one of the links down in the description, and you can join my Discord server there. And that's usually where I post any you know sort of you know late news that I'm going to be late or that kind of thing. So yeah, huge apologies for being late, but you know that's how it goes, and I greatly appreciate you guys hanging out until I'm able to get over here. So here we are. Yay! Let's see. Let's take a look at this other one. I haven't looked at these in quite a while, so let's see what they're showing off, if anything. Real-time solar wind. Oh, that's cool. Real-time solar wind. Pretty awesome. Okay. Pretty much shows exactly the same thing that we were just looking at. So a little temperature increases there, and then temperature drop, temperature increase. You know, it's a very dynamic place, right? Should expect that kind of stuff. Faux show. Faux show. Let's see. Yeah, then they usually have, you know, some kind of interesting story. Pretty cool. Oh yeah, they do a sunspot count, right? So as of today, apparently there were 17 sunspots. We'll look at the sunspots here in a little bit. Sort of a, a plot showing sunspot activity, K index, which most of your radio people already know about, or the KP index, that is. Pretty quiet, even though we have yeah, sort of some coronal holes, but we'll get into that also. There's another site that I like to. My only real gripe about this site um, is this plot right here. Okay, this is from the All Sky Fireball Network. Okay, and I've got a big gripe with this as a scientist. Okay, as a scientist, there are error bars in measurements always. Now, what they're showing you here is the calculated orbits of meteors that have impacted the Earth. You know, they've come through the atmosphere along some path, right? Some trajectory. And if you have two or more all sky cameras that can see these things happen, then you can do a triangulation. You can um, uh, make a guess as to where they're, you know, uh, um, what the orbits actually were, and that's what they're doing here. The gripe that I've got about this plot is that the uncertainty in the measurement that is made at Earth, right, in the atmosphere, is um, is relatively large compared to these orbits. Okay, these orbits are, you know, millions and millions of kilometers, right, around. And we see them, we see the meteor for, maybe 20 kilometers or so. Okay. And we make a measurement of that and then try to calculate these orbits. And these orbits are so inaccurate that in truth, a blur, right? That's how accurately we know these orbits. These would all be so fuzzy, so big in terms of the uncertainty that you wouldn't be able to see the individual orbits. And I know what they're trying to do. They're just trying to, you know, show people, non-scientists, the, give them an idea of what's going on and all of that. In fact, that's the sun. Here's the Earth, right here. So here's the impact of the Earth. Here's the sun, right? So here's the orbit of Mercury, Venus, Earth, Mars, and Jupiter. Okay, so yeah, I'm just saying that um, you cannot uh, predict an orbit this precisely with the data they have. I know what they're up to. I understand. It's just a little deceptive, and I've tried to contact them, but they don't want to listen. So there's no kind of response. Anyway, so spaceweather.com is definitely very, very awesome. The other one that I was trying to remember the other day is this one called HelioViewer. HelioViewer, I think it's .com. And I'm not going to hang too much on this one. I'll let you all play with this one. Maybe it's org. Yeah, that's it. It's 4 a.m. No, yeah, it's 4 a.m. You guys are 1 hour ahead of UTC. Is that right? You guys are amazing. So here's HelioViewer, and it's kind of cool because this is just looking at the sun, right? These are just different views of the sun. You can choose your observation date and time. You can use these little arrows to jump between either days, right? So there's a day jump. There's another day jump. So very, very cool. You can also, how can I do this? I think, can I? Yeah. So you can zoom in, right? Obviously, there's an active region on the sun right now. Let's go back to the newest one. The sun, of course, is rotating from this side over to this side, right? So it's rotating. That would be east to west, right? Because this way's north, this way's south, this way's east, this way's west. And so the sun is rotating. The sun takes about 25 days or so to make one complete rotation. One of the mysteries of the sun, however, is that the um, the equatorial regions rotate. I don't know if it's faster or slower, but different than um, more northern or southern um, regions. So it doesn't all rotate at the same time, and Jupiter does exactly the same thing. Saturn does exactly the same thing. Uh, they aren't. Well, supposedly, at least the atmospheres aren't solid, right? So yeah, you're going to have some weird differential rotation, and Nobody knows why. Nobody knows why. But this is a really, really cool site because you can choose your your data source, right? We can look at SDO, SOHO, stereo. There's a couple others here. So yeah, if we want to look at stereo A, there it is. And then you can choose which instrument. Apparently, there's only one. Let's go back to SDO because there's a lot of instruments there, um, or there's a lot of measurements there, uh, supposedly. HMI, AIA. Yeah. So this is looking at the sun. Uh, all of these images here, or most of them, yeah, I think all of them are in the ultraviolet, right? So this is 94 angstroms. 94 angstroms. And when you look at the sun or you look at anything at different wavelengths, what you're essentially doing is you're looking at different elements, different atoms um, um, in the atmosphere of the sun, and usually those occur in different places, right? So you can sort of see that with the 94, right? You sort of have this, you can starting to see maybe a little bit of the corona here, maybe some coronal holes, of course, the active region. But as you move to a little longer wavelengths, 131 angstroms, it changes. Now, don't be deceived by the colors, okay? The colors are just there. Um, Solar astronomers have sort of agreed that, okay, when we look at the sun at 94 angstroms, that's the wrong one. We're going to color it sort of a darkish green, right? And that's just so when somebody looks at this, they don't have to be like, oh, okay, well, what wavelength is that? Okay, the actual data that is coming down, right, that it's actually seen by the detectors on the spacecraft, is not dark green. Okay, it's a grayscale. It's just dark and bright, and that's it. So we humans here on Earth are coloring these just to make it a little bit easier for us to understand what we're seeing. The color also, can enhance, right? It can enhance things as well. So we can just move up in wavelengths here. That's 171 angstroms. You can see that there's some pretty cool magnetic field lines if this thing ever decides to oh, zoom in here. You can see that material, right, is following these huge magnetic fields. Now, I think there's an Earth scale here. Can I move that? Yeah, okay. So there's the Earth. There's the size of the Earth. Do you see that little thing there? So these are huge structures, right? I mean, the Earth disappears in this stuff for sure. Huge structures, and these magnetic field lines not only loop around, but they extend. They go. Whoop! What did I do? Very very far. These extend, way out. They go out into the solar system. That's actually part of the solar wind. It makes up the particles that are part of the solar wind. We can just sort of scroll through the rest. It's This is the best way, in my opinion, to look at the sun, right? Maybe not with helio viewer, but with any of these tools. So here we're starting to see more of the corona, and we can see the coronal holes, right? So these are holes in the sun's upper atmosphere, the corona, and even along the edge you can see holes. right? These big divots. But usually there's some holes in the north or south pole, and oftentimes there are also um, um, the equatorial holes. If there are um, equatorial holes, there is material that can be shot out like a fire hose, right? And we see that on Earth, and for sure the radio guys, you know about those kinds of things for sure. When you have a coronal hole, you have a lot more um, uh, activity in the Earth's field, and I don't know if that makes it better for radio or worse. I want to say it makes it better, but maybe one of you can tell me. So, all right, let's keep looking at the sun here. So that was 193 angstroms. Here's 211 angstroms. We're seeing more of the corona now, right? And again, these colors are artificial colors. They're not the actual color. We cannot see in the ultraviolet, um, and the cameras that we use can only see shades of gray. So we're adding colors to these. Starting to see some prominences here. Right, here's some prominences along the edge. Those are just active regions. This active region also has prominences, but because we're not seeing it on the edge of the sun, we really can't see them sticking out all that well. So let's see, 335 angstroms. You can see there's some systematic effects here with their uh, imagers here in the background. Kind of interesting. That active region is pretty cool looking though. So here's 1600 angstroms. And I guess there is a 4500 angstrom one, which would be visible. Yeah. All right. Another pretty good site, just to give you a sense of everything space weather, um, is Ben Davidson's site, spaceweathernews.com. I encourage you to check Ben out. He's a pretty smart dude. He's come up with some interesting ideas, and uh, he's been studying the sun for quite a while. I like this site because it's sort of a clearinghouse for everything. Um, um, Solar images, space weather, all of it. So let's just scroll down. You'll see sort of the same things. He makes these. I think he makes these movies with HelioViewer, if I remember right, and it's just the past 24 hours on the sun. So yeah, he does this for each. Well, I guess not each wavelength, but a few wavelengths. Here's his latest thing. He does a daily, at least a daily update report. I guess he calls it. Um, uh, looks like it should be moving, but yeah, I guess it is. Yeah. Okay. Yeah, I'm seeing a little bit of rotation there. So that's very cool. Um, so then we get into X-ray fluxes, right? X-ray flux from the GOES satellites. GOES is a satellites that look at Earth, and it just so happens they have instrumentation on there to measure the X-ray flux as well. And looks like it's been pretty quiet for at least several days. here is where you'll see flares, right? You got your A flares, your B flares, C flares, M flares, and X flares. So yeah, sun's been pretty quiet. Usually, when you have a active region, you'll have some flares, which will kick up the X-ray flux. You'll notice that it's in watts per square meter, right? So that's kind of an interesting, gives you an idea, at least in terms of how much power is actually being seen. Of course, this is in the X-ray, right? It's not in the um, um, visible, so it's kind of hard to translate that, I guess. Let's see, more solar wind stuff. Basically, the same as we saw before. Um, Measuring the local magnetic field, right? They have a magnetometer on GOES as well, and so we're seeing uh, the magnetic field strength in nanotesla. GOES 15 and GOES 14. And yeah, as you can see, the KP index here is really low. Whoop, really low. Not a lot of activity. These spirals are pretty cool when we have any kind of like coronal mass ejection. Uh, they'll and this is just a model, right? This isn't actual data, but they'll collect a little bit of information about the coronal mass ejections, and then they'll create these models to show how those ejections are moving through sort of the inner solar system, right? And so what we've got is Earth here. Here's Earth. Um, Venus is the green one. Venus is over here. Let's see, do they show Mercury? Yeah, Mercury is, I guess, here. So this is showing us several days worth. Okay, yeah, here, up here. So 218, March 6th, March 6th, plus 10 days. So yeah, the past 10 days or so. Um, so as you can see, there was a little tiny CME there. And so these are just different perspectives on that. Again, here's Earth here. Here's sort of a horizontal view of that. So here's Earth as well. So that's very cool. When they have um, big ejections, you can sort of watch them happen, and you can get a prediction as to how strong they're going to be and all that. So here's proton flux and electron flux. So they're actually counting protons and electrons. This up here was X-ray flux, right? So this is light, photons, and these are protons. So particles per square centimeter per second per steradian, which is a steradian is just it's a three-dimensional angle, right? Because we do live in a three-dimensional world, supposedly. So these are the electrons. Whoop! These are the electrons, electron flux, and again, particles per square centimeter per second per steradian. And you can see, 10 to the third, 10 to the fourth, 10 to the fifth. So some of these, from GOES 15, oh, come on, GOES 15, energetic electrons are getting up there, 100 million particles per square centimeter per second. Not bad. So just more data there. I haven't looked at these in quite a while, so I don't remember exactly what they're showing. Ben is really into hazards, right? He's looking for bad stuff to happen. So he gets all excited, you know, um, when something bad happens. He's constantly on alert. It's one alert after another, which to me is sort of a turnoff. Real time ionospheric map. Not. I guess yeah. You radio guys might understand these kinds of maps a little bit better than I. It has something to do with the ionosphere, right? Ionosphere, the activity in the ionosphere shows the critical frequency of the F2 ionospheric layer. Okay. Okay. Oh, okay. All right. So this is in megahertz. So different colors, the critical frequency. See, I'm not that much of a radio guy, so I'm not quite sure what that means, what the critical frequency is. I know that there's an angle, right, that changes depending on ionospheric altitude, which has to do with space weather, but I'm not quite sure what this critical frequency is. If you guys know what that is, let me know. Let me know. I want to, this live stream goes back and forth, right? I'm not here just to tell you things. I'm here to ask as many questions as I possibly can. Oh yeah, here's the aurora forecasts for the northern hemisphere and the southern hemisphere. Of course, the North Pole and the South Pole is where all the action is. And yeah, if you haven't seen the northern lights or the southern lights yet, make try to make it a point to do that because they are awe-inspiring. They're it's yeah, they are absolutely fantastic, absolutely beautiful too. One-time empirical ionospheric uh, correction model. Not quite sure what all this information is showing. Communications conditions. Okay, so you radio guys will definitely understand this, right? Six 6 meter band, 4 meter band. It says band closed. Huh? Not quite following that. Um, but I guess in the 80 meter to 40 meter band, the conditions are good. 30 to 20, they're fair. Everything below 20 looks like it's poor. So the frequency will change depending on the level of ionization happening. So the more it's ionized, the higher frequency will reflect off of it. Okay, cool. So yeah, that provides an interesting map of that. I don't know. Are there other sources of this information other than this site that you guys access? If so, as I said, get on to my Discord. You can post links there for sure. Because yeah, I'd like to learn a lot more about this. I'm pretty much completely in the dark. So daytime sunlit Earth side will propagate higher, nighttime lower due to less ionization. Add more solar activity, you'll have higher frequencies. Okay, I'm following you slightly, just slightly, Jill. I'll get there. The density of my skull is like neutron star matter, so I can be pretty dense. Be pretty dense. Here's the um, sunspot count over the past several years, right? This is January 2019, 18, 17. So this goes back 20 years, right? This is a 20-year thing here. Same thing here, right? Except it's measuring radio flux as opposed to sunspot number. Interesting, right? Interesting that there's a correlation, right? A pretty good linear correlation between radio flux and sunspot number. Makes you scratch your head and go, interesting. Daily solar wind at Soho, electron fluence, don't know what that is. So comparing the different solar cycles with different dates, you can definitely see that it's been decreasing this past several years. All right, well, very cool. Well, I'm going to cut this short tonight because I was running a little bit late, and I do greatly, greatly appreciate you all coming in here. But I also know that you have other things going on, so I don't want to hold you up any more than what we have to. We've been looking at the sun, and that's very, very cool. Um, let's see, can I? Is it going to let me unshare my screen, or am I going to be? Ah, there it goes. There it goes. I think I'm back. I think I'm back. Let's find out. I'm going to wait till the live thing. Yeah, okay, I'm back. All right, I'm going to get out of here. Thank you extremely, extremely much for hanging in there with me while you wait for us all to stare at the sun for a little while. Those are some pretty good sites. Encourage you to take a look at them. And yeah, I think I'm going to get out of here for now. As I said, thanks for hanging in there with me. Make sure to share this around. I definitely want to grow the crowd in here a little bit. I like seeing the conversation I'm in the chat. I think that's extremely awesome. Um, yeah, I think I'm gonna call it a night to remember. So, all right, take care, everybody. There's Uncle Bill. Don't forget to bang that up button. And I'm just gonna add, hit the down. I mean, if I'm looking for um, positive, any kind of feedback, constructive criticism. That's the word. So if there's something really really annoying that needs to be eliminated, or if you like to see something new, some kind of new stuff, this is a daily live stream, so I don't try to pack in a lot of stuff. I don't try to do the same thing every single day, um, uh, because yeah, I'm not going to be a machine here. I mean, if you want to look up all this stuff yourself, you probably can. I'm trying to add a little bit of passion and a little bit of conversation, right? So, but yeah, any ideas in terms of making this live stream better? I am I am all ears. I'm all ears because that's what I want to do, is just make it better. And you know, um, 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 uh, Uncle Bill, I will try to be awesome. I don't claim to be awesome at all, so I don't know if I can stay awesome or not. But this sure is a lot of fun, and yeah. All right, I'm gonna get out of here for now. Peace. Cheers. I will see you on the spin tomorrow night. I will be back at 2 hours UTC. No more late. No more late, not for a while. Don't foresee any kind of pauses, any kind of lateness, anything at all. So I think we should be smooth flowing here for the foreseeable future. All right. Take care, everybody. Have a great night. Have a great day. and I will see you on the spin. Okay, bye.